This type of problem is called a work type problem, and generally it splits the work into two separate people or two different machines or more. So here we have Joe can paint a house in 15 hours and Jennifer can paint the same house, type of house, in 18 hours. And then it'll ask, how long will it take them to paint the same type of house. So the critical idea here, and there's a couple different ways of looking at it, but the way I look at it is this. Here Joe can finish the entire house in 15 hours. So my question is, how much will he finish in 1 hour? So if he only paints for 1 hour, how much of the house will he finish? Well, if it takes one whole house to be painted in 15 hours, in 1 hour he's only going to finish 1/15 of the job. So then the next question would be, well, how much of the house in 3 hours? So that would change the fraction, because since he's working for 3 hours now, it would be 3 out of 15, or 1/5 of the house. So the idea is the amount of time it takes Joe to paint the house is going to go on the bottom, and the amount of time, or the amount of the house that he finishes, is going to be the fraction of the time he spent painting out of that 15. So if he sat there for 15 hours, he would finish 15 out of 15, or one complete job. So now, while we're doing Joe, and we throw in Jennifer into this, if Jennifer is only working for 1 hour, she's going to take 18 hours to finish the house. So she will finish 1/18 of the job in 1 hour, and 3/18 of the job in 3 hours. So if you're going to put them working together, this is how much they would make or paint working together. 1/15 plus 1/18 in 1 hour, which is, more than individually. And then here you'd have 1/5 plus 1/6, which, if I remember right, is 11/30 of the house. So that's like a third of the house that they finish in 3 hours. So my guess would be about 9 hours it would take them, but I want to be a little bit more precise about that. So the unknown here is that top number. How long? Together. So that would be the x. So if it's going to be x, our equation is going to be this. Joe, he's going to finish x/15 of the job, because it takes him 15 hours to finish an entire job. Working together, they're going to work x hours. We're going to add on to that Jennifer's, and I'll just put Jen up here. She's going to work the same x hours as Joe does, but her fraction is out of 18, because it takes her 18 hours to finish the job. And the total amount that we want here is kind of like when we were dealing with just Joe. If he worked for 15 hours, he would finish 15 out of 15 of the house, better known as one whole job. So this is, I think of it as one job. So working individually, he would take 15 hours, she would take 18 hours, but we're trying to find, if they work together, this common time frame that they're going to finish the job together. So the first thing about this equation is it's got fractions, and most people don't like it. So what you do is you multiply by the common denominator of 15 times 18. Now if you multiply this one, and I'm not going to multiply them together just yet, 15 times 18, each single term on both sides of the equation. When you do it in this fashion, here the 15s are going to cancel, so you're going to be left with 18x. Here, the 18s are going to cancel, one on top, one on the bottom, and you're going to be left with 15x. So on this side, you're going to have 18x plus 15x is equal to, and now I can use my calculator and figure out what the heck 15 plus 18, or I'm sorry, 15 times 19, 15 times 18 is 270. So this side is 270. And then you just have to solve for x. So this is 33 is equal to 270. And then divide both sides by 33 to find that x is equal to 270 divided by 33, 8.2. Now x is how long together. So this would be 8.2 hours. Now my guess was 9 hours, and I was quite a bit off there, but that was just an estimation. So together, Joe and Jen can finish this job in 8.2 hours, where individually it would take Joe 15 hours to finish the job and Jennifer 18 hours to finish the job. So working together, they can save themselves a lot of time to finish that one job. A similar type problem with the work type problem. Here we have Joe can paint the house in 15 hours, but in this case we know how long it takes Joe to work with Jennifer. It only takes them 10 hours to paint a similar house when Jennifer works with Joe. And here we want to kind of break it apart. How long would it take Jennifer on her own to paint the same type of house? Alright, so the setup is basically the same. We deal with the 15 hours for Joe, so here's Joe, here's Jen, and here's the job. So Joe can finish the job in 15 hours, so we'd go something over 15. We're going to add on to that Jen, and we don't know much about Jen because that's what we're looking for, and we know we're going to complete one whole job. So this 10 hours, this working together, if we go back to the previous problem, the x that we were solving for was the working together, and they were exactly the same in these two positions. So this 10 hours that we have here where they're working together would go in these two positions. It is 10 hours that they're working, so Joe is going to finish 10/15 of the house, and Jen is going to finish 10 whatever of the house. So the unknown is going to go down here. I'm going to put it as x. Alright, so it's similar in the way to solve it. You're going to multiply everything by the common denominator. So we're going to multiply each one of these terms by 15x. Oops. There. So when we multiply by 15x, here the 15s are going to cancel, and you're going to be left with 10x. Here the x's are going to cancel, and you're going to be left with 15 times 10. And over here you're just going to get 15x. Alright, so we're going to get 10x plus 150 is equal to 15x. And we're trying to solve for x. So the goal is get the variables on the same side, so I'll move the 10x to this side. And when you move it, you're going to be changing its sign or subtracting it. So you're going to get 150 is equal to 5x, and x is going to equal 30. And again, x is the number of hours that Jennifer would be able to do the job on her own, so this would be 30 hours. So if Joe can finish the job in 15 hours, they can work together and finish the job in 10 hours, but Jennifer on her own, it would take her 30 hours to finish painting a single house.